Welcome back, everybody. In this section, we really focus on just one function, the absolute value function. We spent some time looking at it, a little time looking at it before. In this section, we go into greater detail about how to calculate it and how to graph it and solve equations and inequalities involving it. So let's get started. So first of all, recall the definition for the absolute value function. We've just seen that it was an example of a piecewise defined function. So here, f of x, which is the absolute value of x, is just plain x if x is greater than or equal to 0. In other words, if x is positive, it's basically the identity function. But if x is negative, then you return the opposite of x. So you want to be careful when you see just this, that you don't think that automatically refers to a negative number. For example, I don't think we've ever had a v together. So if I said to you, what is this? Is this positive or negative? You don't want to think, okay, well, it's negative. Because what if v was itself negative 12? If v were negative 12, then the opposite of v would be positive 12. So anytime you see a dash, you don't want to just kind of automatically think of that as a negative number. It means the opposite of whatever x is. Okay, so let's try calculating. Important thing to remember is that what absolute value tells you is how far a number is from 0 without regard to direction. Since it gives you a distance, it's always a positive number. If you think about it, distance is always positive. If somebody is standing 6 feet away from you, that's good, right? If somebody's standing 6 feet in front of you, they're 6 feet away. If somebody is standing 6 feet behind you, they're still 6 feet away, right? It's still positive 6. You would never say somebody behind you is negative 6 feet in front of you, right? They're just 6 feet away. Absolute value, always a positive number. All right, so let's try. The absolute value of negative 7, how far is negative 7 away from 0? It's 7 units away. How far is 21 from 0? It's 21 units away. Absolute value is pretty straightforward. As far as where it fits for order of operations, it kind of functions like parentheses or brackets do. So for C here, where we see 2 times the absolute value of 3 squared minus 5 squared, we're going to start by doing the part inside of parentheses or inside of the bars. So we have 3 squared, which is 9, minus 5 squared is 25. So then still inside the absolute value bars, 9 minus 25 is negative 16. So then 2 times the absolute value of negative 16. The absolute value of negative 16 is positive 16. And so we finish with just plain 32. Okay. For the next one, we have negative 4 times the absolute value of negative 6. The absolute value of negative 6 is just plain 6. So negative 4 times positive 6, negative 24. Okay, so calculating with exact absolute value is pretty straightforward. Just remember that it tells you the distance of a number from 0. All right, so we wanted to take another look at the graph of the absolute value function. So we had seen this before a couple of times. So we could start by evaluating the function a couple of places. So the absolute value of 0 is 0. The absolute value of 1 is 1. That's not very exciting, right? The absolute value of negative 3 is just going to be positive 3, right? So for some positive values, we know that what we put in is what we get out, right? And then for negative values, what we're going to get out is the opposite of what we put in. So the absolute value of negative 1 will be 1. The absolute value of negative 2 will be 2, and so on. So that's what gives the absolute value function its kind of characteristic V shape. And then in hindsight also, we saw that the absolute value was the union of two linear functions, right? That it's the identity function if x is greater than or equal to 0, and the negative of the identity function if x is less than 0. So that's why when x is positive, you just get a line with slope 1 and y-intercept 0. When x is negative, you get a line with slope negative 1 and y-intercept 0. So that's our graph, our basic graph of the absolute value function. To graph a variation on that, y equals 2 times the absolute value of x plus 1, we can use some transformation ideas to help us out with that. So considering absolute value of x to be our basic graph, the x plus 1 is going to represent a left shift by 1 unit. And if you think about it, that makes sense because you want to think, okay, the absolute value is always greater than or equal to 0. So what would I substitute into here to make it so that the smallest possible value comes out? Well, if I put in 0, we'll get a 1 out, neglecting the 2, of course, just for the absolute value. If you put in a 0, you'll get a 1 out. What would you plug in to get a 0 out? You'd have to put in -1. So the smallest value you're going to get out of this is, out of the whole expression here for y, is going to be 0. And that's going to occur when x is -1. So that represents a left shift by 1 unit. So normally we might think, okay, well, based on our work up here, we'd think, okay, well, it's just going to be just this regular V shape with 2 lines of slope 1 and -1 respectively. But you notice that there is this factor of 2 in the front. Multiplying a function by that constant 2, which is bigger than 1, is going to represent stretching the graph vertically by a factor of 2. So you can also do this by just dropping in a couple of points. For example, when x is 0, what's y? 0 plus 1 is 1. Absolute value of 1 is 1 times 2 will give you 2. So 0, 2. The shape is going to have a vertical axis of symmetry through the line x equal 1. So if you think about it, that means that at -2, it will have to also be 2. But we can try doing the calculation just to be sure. When x is -2, -2 plus 1 is -1. The absolute value of -1 is 1 times 2 gives 2. So we'll have y equal 2 again. And so here this will give us our V shape. But as you can see, this time it is more steep than it was before. Okay, the slope of each piece now is 2 rather than 1. So for each piece, I'm going up 2 and right 1. All right, so relative to our regular absolute value graph, this one is going to be a bit steeper. Okay, so we've taken a look at a couple of graphs. We want to look at next how you solve absolute value equations. In math, there are a variety of different absolute value equations that you can see. We're going to focus just really on one certain type. So what you'll see here is all equations of the form absolute value of A equal B, and B will be some number. When B is positive, you're going to have solutions when A is B or A is the opposite of B. If B is negative, there will be no solution because, as you recall, the absolute value is always non-negative. Okay, so let's try. The key to getting all of this done correctly is to remember that absolute value tells you the distance of a number from 0. So when you see an equation like this one, the absolute value of x is equal to 4, you want to think, okay, well, this says what numbers are 4 units away from 0? So here's 0. The 2 numbers that are 4 units from 0 are -4 and 4. So there are 2 solutions, -4 and 4, 2 individual numbers. Okay, and that's it. The absolute value of 2x plus 1 equals 5. Here, I don't know what x is, so I don't know what 2x plus 1 is, but I do know where it is. I do know that 2x plus 1 is 5 units from 0. That means that it has to be either 5 or -5. So either 2x plus 1 equals -5 or 2x plus 1 equals +5. This gives us 2 small linear equations that we can solve. So we'll get x is -3 as one possibility, or x is 2 as another possibility. So again, there are two solutions, -3 and 2. You'll notice in each case that we're reporting the x values that satisfy the equation. Okay, the absolute value of 4x minus 1 equals -8. We don't have any work to do right here. We can just stop and say that there's no solution. The reason for that is that the expression on the left has to always be greater than or equal to 0. It's a non-negative number, and all non-negative numbers are never equal to -8. So there's no solution to that one, and you don't have to do any work to show that that's true. Okay. When you are doing this solving absolute value equations and using this kind of thinking that, like we used up here, 2x plus 1 could be 5 or -5, you need to do that thinking after you've isolated the absolute value. So in this example, 3 times the absolute value of 4x minus 1 equals 10. In this one, I don't want to be thinking -10 and 10, okay? I need to first isolate the absolute value part. So we'll have the absolute value of 4x minus 1 equals 10/3. Okay, we've isolated the absolute value. Now we'll divide it into two separate equations. So 4x minus 1 is -10/3, or 4x minus 1 is +10/3. Okay, so this is two little linear equations. They do involve fractions, but that's okay. So let's go ahead and solve those. So we're going to add 1 to both sides. 1 is the same as 3/3, right? So we'll have 4x is -7/3. Then we'll divide through by 4. So x will be -7/12 in the first case. And then for the one on the right, 4x minus 1 is 10/3. We're going to add 3/3. So 4x will be 13/3. And then x will be 13/12. So here our two solutions are -7/12 and 13/12. Okay, and that's it. Very important to remember to isolate the absolute value before you start thinking about employing the meaning of the absolute value itself. Okay, one more of these, and this one, we have the absolute value piece is already isolated. We have the absolute value of 3x minus 1, it's equal to 7. So we can say, well, I don't know what x is, I don't know what 3x minus 1 is, but it's 7 units from 0. So that means that it either needs to be at -7, or 3x minus 1 is +7. Okay, one or the other. So we'll solve each of these equations separately. 3x, we're going to add 1. 3x is -6. And then that make x be -2. Here, 3x is 8, so that x is 8/3. All right, so I wanted to do one more thing, which was to show you how to solve this particular equation graphically. So we're going to do this on the computer, actually. So let's see how that looks. All right, so once again, we're here looking at Desmos. We want to see if we can use that to help us solve our absolute value equation. So this one was the absolute value of 3x minus 1. So what we're going to do is we're going to graph y equals the absolute value of 3x minus 1. Okay, so that is the picture of the left-hand side of our equation. And then the right-hand side was y equals 7. Okay, so that represents the right-hand side of our equation. So if you think about what it is that we're trying to do when we're solving an equation, we want to find the values of x so that the left-hand side will equal the right-hand side. So taking a look, we have our absolute value function shown here in red. We have our right-hand side, which was constantly 7, shown in black. And we wanted to find out where the values of x are that make this true. And so it looks like they're at -2. And then, according to the computer here, about 2.667. And if you work it out, that's the same as 8/3. So that is a way of solving this equation graphically. Doing it by hand, it can take longer to actually produce the graph than to go through the method that we showed, but I wanted to show you one example done on the computer. All right, so again, we've seen how we can solve this equation, absolute value 3x minus 1 equals 7, by graphing the left side, graphing the right side, and finding the values of x for which they cross. Okay, so I want to work on solving inequalities next. So basically, in our book, in this section, there's two different kinds of inequalities. Either absolute value of whatever it is, doesn't matter, is less than or equal to some number, or the absolute value is greater than or equal to some number. The only difference between the first cases, shown here, and the second cases, shown here, is whether it's which direction it is. Is it basically less than or basically greater? In the first case, the only difference between less than or equal are the endpoints included when you write the answer in interval notation. Are the endpoints included? If it's less than, they're not. If it's less than or equal to, they are. Parentheses, square brackets. For greater than, it will be just parentheses. For greater than or equal to, square brackets. So that's the only difference. Other than that, there are two basic kinds of absolute value inequalities. Either absolute value is smaller than something or absolute value is bigger than something. We'll take the first one first. So remembering that absolute value tells you the distance of a number from 0. That's the key to getting this done. So here in this first one, the absolute value of x is less than 9. Again, as with equations, I don't know what x is, but I do know that its distance from 0 is less than 9 units. So that means that x has to be in between -9 and 9. So our answer here is -9 to 9 in interval notation. Okay, notice that on this, the answer is an interval, wherein when we were doing equations, it was two distinct x values. Here it's an interval. Here we have the absolute value of y is less than or equal to 5. So I don't know where y is, but I do know that its values are between -5 and +5. So close bracket, -5, 5, and then close bracket. Big difference between this one and the prior example is that the endpoints are included on this one because of the or equal to. Okay, absolute value of x is less than -3. So on this one, there will be no solution, and there's no work to do here because the absolute value of x is always greater than or equal to 0. And so how could it be smaller than -3? Incidentally, if you liked the graph way that we were doing a few minutes ago for the equation, here's the graph of the absolute value. Here's the graph of y equals -3. For which values of x is the V shape below -3? It never is, right? So that's why there's no solution, okay? Absolute value is always greater than or equal to 0. It can never be smaller than -3. Okay, so here we have the absolute value of 3x plus 1 is less than 11. So here again, I don't know where x is. I don't know where 3x plus 1 is, but I do know that 3x plus 1 is somewhere in between -11 and 11. So if -11 is less than 3x plus 1, which is less than 11, this gives us what's called a three-part inequality. I'll leave it to you to figure out why. So here we're going to take and isolate x by subtracting 1 from all three parts. So this will give us -12 is less than 3x is less than 10. And then we'll divide through by 3 to get -4 is less than x is less than 10/3. So our final answer is -4 to 10/3. And again, that will be in parentheses because it said strictly less in the original problem. Okay, try one more. The absolute value of 4a minus 9 is less than or equal to 10. So again, 4a minus 9, I don't know where it is. It's between negative 10 and positive 10. If its distance from 0 is under 10 units, it's got to be between negative 10 and 10. So let's add 9 to all three parts. So this will give us negative 1 is less than 4a is less than 19. And then dividing through by 4, we'll get negative 1/4 less than a less than 19 over 4. Okay, and then in interval notation, negative 1/4 up to 19/4. Okay, so then in this one, there's a little mistake, but fortunately it's easy to fix. See if you can find it, take a few seconds. Okay, so here's the little flaw. You'll notice in here that the original problem had a less than or equal to in it. In going from here to right around here, I just kind of dropped the or equal to and just made it strictly less, although I remembered it on the right side, okay? And so because of that mistake, you'll see that forever after, it's just less thans, and I finish with a final answer in parentheses, just due to that one little mistake, right? So you want to be really careful, right? One little thing can throw you way off. So let's go back and fix that. It should have had an or equal to all the way through. And our final answer should have square brackets on it. Okay, it's a good idea to take a look back at the end and check and make sure that what you're doing makes sense. Looking at the original inequality, it had the or equal to in it, so I know that the final answer should have square brackets on it. So that's a way of seeing that, you know what, something went wrong somewhere along the way. Okay, all right, so for these first kind of absolute value inequalities, where it was less or less than or equal, we're saying that the distance from 0 has to be within a certain amount. For this kind, you always will get a 3-part inequality, because you're saying the distance is within a certain amount, so there's the 3 parts to that. For the second piece, we have the distance is greater than or equal to some amount. So let's try a simple one first. Here we have the absolute value of x is bigger than 4. So again, for this one, I don't know where x is, but I know its distance from 0 has to be more than something. So it has to be more than 4. So that means that x has to be either over here, less than negative 4, or over here, which is greater than positive 4. So we're going to have 2 separate, or what's called disjoint intervals for this. We'll have negative infinity up to negative 4. And then for the second interval, we'll have 4 up to positive infinity. For this type, where it's always absolute value greater than some number, you will always get 2 separate intervals connected with a union sign, unless it's some kind of weird no solution or all real numbers sort of thing. 2 intervals separated by a union sign. Okay, here we have the absolute value of w is at least 7. So that means that w is 7 or more units away from the origin. So it could be less than negative 7 or more than positive 7. Okay. Again, it's 2 separate intervals connected by a union symbol. Okay, so we have 2 more examples. So in this next one, what I'll need to do before I do anything really is isolate that absolute value part. A big mistake would be for me to say, okay, well, less than negative 5, greater than positive 5, right? What I need to do first is isolate that absolute value. So we're going to begin by taking away 1. And then we'll divide through by 2. Okay, so that looks a lot better. Absolute value of x minus 3 is bigger than 2. So then this means that x minus 3 could be over here somewhere, less than negative 2, or it could be over here, bigger than positive 2, because that's the only ways that you can be more than 2 units from 0. So x minus 3 is less than negative 2. X minus 3 is bigger than positive 2. We'll add 3 to both sides. X is less than 1, or x is greater than 5. This gives 2 separate intervals, negative infinity to 1, union 5 to infinity. A lot of times people get confused. They get they get bogged down trying to figure out, okay, when do you turn the sign around? When do you make it negative? Do you turn the sign around and make it negative? One or the other. To try not to get confused by that, I think it's helpful to make the picture and to think in terms of distance. Okay, I'd recommend doing that. So here, absolute value of 4m plus 1 is greater than or equal to 9. So then that means, well, where could 4m plus 1 be? Its distance from 0 is 9 or more units. So maybe it's over here someplace. Or maybe it's over here somewhere, right? We don't know. It could be one or the other. So we'll have 4m plus 1 less than or equal to negative 9, or 4m plus 1 greater than or equal to positive 9. Okay, so then solving each of these two inequalities separately, awkward silence. Okay, so it looks like m is less than or equal to negative 5/2, or bigger than or equal to 2. Okay, and so that will be the solution to this one. Okay, so again, remember in working with these absolute value inequalities, if it's something less than or equal to some number, you're going to get a 3-part inequality, and you're going to get just one interval for an answer. Okay, if it is absolute value greater than or equal to some number, then you're going to get 2 separate intervals, and you're going to have that union symbol in there joining together those 2 separate intervals. Okay, we just have a little more. So here the absolute value of 3x plus 7 is greater than negative 4. So you want to think about that for a second. Is that no solution? Well, this one is actually all real numbers. I know that that can be confusing. You want to think about what is being said here. Absolute value of 3x plus 7. Whatever that is something that is greater than or equal to 0, right? Which numbers that are greater than or equal to 0 are bigger than negative 4? Well, they all are, right? So that's why it's going to be all real numbers. Again, if you liked the graph way of thinking about this, which we'll do more of here in a minute, then here might be a nice way of thinking about it. So the absolute value of 3x plus 7 has its minimum at negative 7/3, and then it's going to open up like that. Right, it's going to look something like that. And then we want to compare it to the number negative 4. Okay, for which values of x is the v above the pink line? All of them, right? No matter what x is, that v is going to be above the pink line. Okay, so that's why it's all real numbers. Okay, I wanted to do one more of these, and especially relate it to how we did the graph. So let's take a look. We're going to solve each of these the way that we have been. So absolute value of 3x minus 1 is less than 7. So this one was a less than, so it will turn into a 3-part inequality. So we'll have negative 7 is less than 3x minus 1 is less than 7. Let's add 1 to both sides. And then divide through by 3. Okay, get -2 is less than x is less than 8/3. Okay, here absolute value of 3x minus 1 equals 7. This was the equations that we kind of started out with. So here we'll have 3x minus 1 equals -7, or 3x minus 1 equals +7. Solving each of these separately, we'll get -2, and we'll get 8/3. So we'll have two distinct x values, -2 and 8/3. Okay, so then for the last part, we're going to do the absolute value of 3x minus 1 is greater than or equal to 7. So that says that 3x minus 1 is less than or equal to -7, or 3x minus 1 is greater than or equal to +7. So this should feel really familiar by now. And then finally, we'll have -infinity to -2 union 8/3 to infinity. All right, so we want to add to that the graph of some things so that we can relate what we've just done to the graph. All right, so here's our graph from earlier that shows in red the graph of absolute value of 3x minus 1, and then the graph of the line that's constantly 7, shown here in black. So we want to relate this again to the three kind of problems that we did above. Let's start with the inequality on the left. We wanted to know which values of x made it so that the absolute value was under 7. So remember here we're comparing y values. So for this first one, the x's that make it so that the v is underneath the black line. So for which values of x is the v underneath the black line? Those will be all the x's between -2 and 2.667, which is 8/3, right? That's 8/3. So the x's that are between -2 and 8/3 will make it so that the absolute value is under that horizontal line. Anytime we're asking the absolute value to be under some constant, you're going to positive constant, it's going to have a picture such as this, which is why the answer always ends up being a single interval. For the middle, we have the absolute value of 3x minus 1 equals 7. We saw that it was -2 and 8/3. So you can ask, okay, where is my V shape going to cross that horizontal line? Here it crosses in two places, when x is -2 and when x is 8/3. Okay, then lastly, we want to know where is the V shape above the black line? The x's for which the V shape will be above the black line are if x is -2 or smaller, or if x is 8/3 or bigger. So if you think about it, when we have absolute value less than some number, that's where it's under that horizontal line, and you're going to get a single number or a single interval for an answer. Where it's supposed to be equal to a constant, you're going to have two x values where that happens. And then where it's greater than that positive constant, that is going to be the two up parts on that v, which is why you end up with two separate intervals. In this case, from -2 to the left and from 8/3 to the right. Of course, realistically, it's probably simpler for you to do this, the algebra steps to solve each of these things, but it can benefit you to have this kind of picture in mind when you go about solving these sorts of problems. All right, so this takes us to the end of this section. Let me know if you have any questions, and have a great day.